In the last chapter, we left home. We raced past planets, crossed interstellar space, and stood in the presence of stars so vast that their deaths could create worlds. But even the most powerful stars are only pieces of something far larger. Now, the scale changes. Individual suns begin to fade into patterns. Stars gather into galaxies. Galaxies assemble into vast families, bound together by gravity and dark matter. We are no longer exploring destinations, we are exploring structure. As our impossible speed carries us forward, the Milky Way shrinks behind us, no longer a home, but a single spiral among countless others. The universe reveals itself not as chaos, but as a vast cosmic web stretching across incomprehensible distances. In this chapter, we will move beyond stars and planets. We will witness galaxies colliding, pass structures so large they defy human intuition, and approach objects that bend space and time itself. And at the end of this journey, we will reach a boundary, not a wall of matter, but a horizon of time, a limit defined by the age of the universe itself. This is part 2, the journey beyond the stars and toward the edge of everything we can see. As we leave dying stars behind, we move toward their beginning. Between the stars lies not emptiness, but vast clouds of gas and dust, nebulae stretching across dozens, sometimes hundreds of light years. These are the raw materials of creation, shaped by gravity, radiation, and time. After 2 hours at our impossible speed, towering forms emerge from the darkness. We have arrived at the Eagle Nebula, home to the pillars of creation. These colossal columns of cold gas and dust rise like cosmic mountains, each one several light years tall. Inside them, gravity is slowly pulling matter together, forming protostars, stellar embryos hidden from view. Infrared light reveals what visible light cannot. Newborn suns igniting deep within the shadows. Yet creation here is fragile. Nearby, massive stars flood the region with intense radiation, carving away at the pillars' surfaces. Stellar winds and shock waves from ancient supernovae erode them grain by grain. The same forces that give birth to stars will one day destroy these structures entirely. Creation and destruction are inseparable. Across the galaxy, nebulae take many forms. Some glow brilliantly as energized gas emits light. Others appear as dark silhouettes, blocking the stars behind them. In some regions, gravity dominates, collapsing clouds inward. In others, radiation tears them apart before stars can fully form. The balance is delicate. When enough mass gathers, nuclear fusion ignites. A star is born. Around it, leftover material flattens into a rotating disk. Within that disk, dust grains collide, clump, and grow, forming the seeds of planets. This process has repeated for billions of years. Our sun was born in a nebula like this one. The atoms in your body once drifted through clouds of interstellar dust long before Earth existed. We are not separate from these regions. We are their outcome. But nebulae are not permanent. On cosmic time scales, they are fleeting, brief moments between chaos and order. The pillars of creation themselves are already fading. In a few million years, they will vanish, leaving only stars behind. What remains is light. and the endless cycle continues. Stars are born, they shine, they die, and from their remnants the universe begins again. From within a nebula, a star feels immense. From outside, it is barely visible. As we continue outward, individual stars merge into glowing rivers of light. The Milky Way, once our entire universe, now reveals itself as a single structure, vast but finite. Within one day, we reach the outer edge of our galaxy. From here, the Milky Way stretches across space as a luminous spiral, nearly 100,000 light-years wide. Its arms are lined with star-forming regions, supernova remnants, and dark lanes of dust. At its core lies a supermassive black hole, quietly anchoring the galaxy with 4 million times the mass of the Sun. The galaxy rotates slowly, completing a single turn every few 100 million years. On that timescale, civilizations rise and fall unnoticed. As we drift farther, other galaxies appear. After 29 days, a massive shape fills our view, the Andromeda Galaxy. Larger than the Milky Way, Andromeda contains over 1 trillion stars. Gravity binds our two galaxies together, drawing them closer at over 100 kilometers per second. In 4 billion years, they will collide, not in violent destruction, but in a slow gravitational dance that will reshape both into a single, enormous galaxy. Galaxies come in many forms. Some are elegant spirals like our own. Others are elliptical, ancient, quiet systems where star formation has nearly ended. Some are irregular, torn apart by past encounters, their stars scattered like cosmic debris. Despite their size, galaxies are mostly empty. The distances between stars are immense. Entire solar systems pass by each other without ever coming close. Yet galaxies are not isolated. After 115 days, we exit the local group, a modest collection of more than 50 galaxies bound together by gravity. Beyond it lies a deeper order. Galaxies assemble into clusters, and clusters arrange themselves along vast filaments, threads of matter stretching across hundreds of millions of light-years. Between these filaments lie enormous voids, regions where almost nothing exists. This is the large-scale structure of the universe, a cosmic web woven from gravity and dark matter, shaping the distribution of everything we can see. And as we follow these threads outward, it becomes clear. The universe is not random. It has structure. It has history. And it is far larger than any single galaxy could ever suggest. As galaxies fall behind us, even they begin to feel small. What once appeared as isolated island universes now reveal deeper connections. Gravity, operating patiently over billions of years, has drawn galaxies together into structures of staggering size. After 3 years of travel, we enter the Virgo supercluster. Thousands of galaxies reside here, bound loosely by gravity, drifting together through the expanding universe. From within, it feels immense. From afar, it is only one region among many. But Virgo is not the full picture. As we continue outward, invisible currents begin to guide our path. Galaxies are no longer scattered randomly. They trace enormous filaments, vast bridges of matter stretching across hundreds of millions of light-years. These filaments intersect at dense nodes where clusters form, while between them lie cosmic voids, regions so empty they challenge the meaning of nothingness. This is the cosmic web. By 16 years, we leave Laniakea, our home supercluster, a gravitational basin spanning more than 500 million light-years. Everything within it, including the Milky Way, is slowly flowing toward a common center, drawn by mass we cannot fully see. Dark matter dominates here. It does not shine. It does not emit light. Yet it outweighs ordinary matter by more than 5 to 1, shaping the universe's large-scale structure like an invisible skeleton. Without it, galaxies would never have formed. Without it, the universe would be nearly empty. As centuries pass, the scale becomes almost impossible to comprehend. After 320 years, we pass along one of the largest known features in the observable universe, the Great Wall. This colossal structure spans billions of light-years, containing countless galaxies arranged in sheets and filaments. It is not a wall in any physical sense, but a reminder that the universe organizes itself on scales far beyond human intuition. Here, even superclusters are merely components. The universe now appears less like scattered objects and more like a single, evolving system, expanding, cooling, and slowly transforming since its birth nearly 14 billion years ago. And yet, for all this structure, there is a limit, a horizon we are approaching. Beyond it, gravity has not yet had time to sculpt matter into form. Beyond it, light itself has not reached us. The largest patterns fade, and ahead lies the final boundary. After centuries of travel at an impossible speed, the universe begins to thin. Galaxies grow faint. Filaments dissolve into darkness. The great structures that once dominated our view slowly fall away. Ahead of us lies not an object, but a boundary. After 1,000 years, we reach the edge of the observable universe. This is not a wall of matter. There is nothing here to collide with. Instead, this horizon marks the farthest distance light has been able to travel since the universe began, 13.8 billion years ago. Beyond this point, the universe may continue endlessly, but its light has not yet had time to reach us. Space does not end here. Time does. Every galaxy we have seen, every star that has ever shone, exists within this cosmic bubble of visibility. Beyond it lies a realm forever hidden, at least for now. Standing at this boundary, the universe feels quiet, not empty, but unfinished. The light that reaches us from the edge is ancient, stretched thin by cosmic expansion, fading into the microwave glow that fills all of space. It is the afterimage of creation itself, a relic of a time when the universe was young, hot, and dense. Here, familiar concepts lose meaning. Distance no longer behaves as expected. Space expands faster than light itself, carrying regions of the universe beyond our reach forever. No amount of speed, no matter how extreme, could cross that barrier. Yet this horizon is not permanent. As time moves forward, more of the universe slowly becomes visible. New galaxies emerge from darkness as their light finally arrives. The boundary retreats, revealing fresh mysteries while concealing others. The universe is not static. It is unfolding. And within it, we are not spectators. We are participants, made of star-forged atoms, capable of asking questions the universe itself does not answer easily. Our technology may be small, our lifespans brief, but our curiosity is limitless. This journey, impossible as it may be, reflects something deeply human: the need to understand where we are, how we came to be, and what lies beyond the horizon. The universe does not owe us answers, but we will keep searching. Because every horizon reached becomes the beginning of another. And this is not the end. It is the start of everything still to come. We have reached the farthest edge of what humanity can observe. Not a wall, not an ending, but a horizon defined by time itself. From a small blue planet, we imagined a journey faster than light. And in doing so, we crossed stars, galaxies, and structures so vast they defy intuition. We followed the universe outward, layer by layer, until even the largest patterns faded into darkness. And yet the most remarkable part of this journey is not how far we traveled. It is where we began. Every atom in your body was forged in ancient stars. Every thought you have is the product of cosmic history unfolding on a tiny world orbiting an ordinary sun. The universe did not just create space and time. It created observers capable of wondering about them. Beyond this horizon, the universe may stretch on forever, or it may curve back upon itself, or it may obey laws we have yet to imagine. We do not know, but uncertainty has never stopped exploration. The edge of the observable universe is not a limit on existence. It is a limit on knowledge. And history has shown that every time humanity reaches such a boundary, it does not retreat. It asks better questions. This journey ends here, but exploration does not. As long as curiosity burns, as long as we continue to look up and ask why, the universe will remain an open invitation, not just to travel outward, but to understand our place within it. And somewhere, beyond the last light we can see, the next question is already waiting.